and welcome. We're going to look at scatterplots, association, and correlation. So up until now, we've graphed univariate data that was quantitative, and the prefix uni means one, variate is variable, and those graphs consisted of histograms, dot plots, box plots, stem and leaf plots, and even cumulative distribution plots, also known as ogives, right? Now we're going to look at two quantitative variables. So we have bivariate data that's quantitative. And in order to graph that, we need another specific type of graph, which is the scatter plot. And in this scatter plot, we can see the average tracking error in nautical miles of the predicted position of Atlantic hurricanes for predictions made by the National Hurricane Center of NOAA, plotted against the year in which the predictions were made. So here we can see the years along the horizontal axis and then the prediction error along the vertical axis. Scatter plots are an appropriate graphical display when you want to show the relationship between two quantitative variables. These displays make it easier to see patterns, trends, and relationships between the two variables, and even occasional extraordinary values sitting apart from the others. So as you're looking at the scatter plot, pause the video and write down how would you interpret the scatter plot above? What story is it trying to tell us? And then you can unpause it when you're ready to review it. So in looking at the scatter plot, we can see that as the years are increasing, the prediction errors tend to decrease. There's also a very high prediction error made back in the 1970s. So the average tracking error for predicted position of Atlantic hurricanes, we want to be as specific as possible, okay, and always relate the problem back to the problem in context, has decreased over time. There appears to be a very high predicted error in the early 1970s. And maybe that decrease in prediction error is made possible because of our advancement in technology. So we're becoming more and more accurate. Relationships or associations are often at the heart of what we'd like to learn from data. So some examples are grades higher now than they used to be? Do people tend to reach puberty at a younger age than in previous generations? Does applying magnets to parts of the body relieve pain? If so, are stronger magnets more effective? Do students learn better when they get more sleep? If we want to describe the association between prediction error and year and the above scatter plot, we need to address the following three things. We need to look at the direction, the strength, and the form. And in addition, we also always want to pay attention to any unexpected values or potential outliers that could appear. Are there any points standing away from the overall pattern of the scatter plot? And additionally, pay attention to any clusters of points or subgroups that stand away from the rest of the plot. That is the end of this first video. Please stay tuned for part 2.